Remember, in the previous part we concluded that the function is continuous at all points except for 2 and 3. Oh, and by the way, this should be at all x values, not a. It should be at all x values except for 2 and 3. So we also said that even though the function is discontinuous at 2 and 3 on this graph, we can still approach a value, so we can have a limit. Now, what is natural to do is to find out if the limit exists at these critical points. Let's call them critical points because we're under doubt. We will have a limit or not. So basically, let's find out what would be the limit as x approaches 2 and as x approaches 3 of f of x. Well, that would be equal to the limit as x approaches 2, and then f of x is x squared minus 6x plus 8 divided by x squared minus 5x plus 6. Now x squared minus 5x plus 6, we found out that this is the same as x minus 2 times x minus 3. It's, it doesn't matter if here is a. The idea is that we are still solving the same thing. So we would have here x minus 2 times x minus 3. Now for the upper side, x squared minus 6x plus 8, let's see if we can solve that. Well, x squared minus 6x plus 8, we can use our shortcut and see what numbers can we have that when we multiply we get 8 and when we add we get minus 6. Well, if we use minus 4 and minus 2, the multiplication gives 8, and minus 4x minus 2x gives us minus 6x. So this notion, this term would be equal to x minus 4 times x minus 2. And on the lower side we said we would have x minus 2, x minus 3. Now if we cancel out x minus 2 and x minus 2, we're left with x minus 4 divided by x minus 3. So our limit can be written as, let's write it below, we would have the limit as x approaches 2 of x minus 4 divided by x minus 3. Now if we substitute 2 into x, we would have 2 minus 4 divided by 2 minus 3. So we would have minus 2 divided by minus 1, and that's equal to positive 2. So we would have a defined value, meaning that in this case, if we approach the value to 2 from the left side and from the right side, we are approaching the value of 2 on the graph. That's how it would look like graphically. Let's see what happens when we approach x at 3. And let's have a look that at the point of 3 we have a critical point, because we would have 3 minus 3, which is divided by 0. So how would that look like? Because 3 minus 3 is 0, we would have x minus 4 divided by 0. So if we approach 3 of x minus 4 divided by x minus 3, we would have 3 minus 4 divided by 3 minus 3, and that's minus 1 divided by 0. Okay, but then think about it this way. What if we have x approaching 3 from the positive side and from the negative side? Would we have the same result? And the answer is no, because if we approach 3 from the positive side, then the x value would be, let's say, 3.0001 minus 3, we would get 0.0001 for instance, and we would divide minus 1 by a very small number, and as a result we would get a very negative number. But what happens if we do the opposite and we approach x from the negative side of x minus 4 divided by x minus 3? Well, we would have 3 minus 4 divided by 3 minus 3, but now we would have minus 1 divided by, again, we can see that we have 3 from the negative side, so let's say 2.9999 minus 3 would give minus 0.0001. Minus 1 divided by a negative very small number becomes a very positive large number. So we can see that the limit is actually approaching different values, and it's not even defined as a limit. We're not approaching a value, we're approaching a concept, a very large number. And when we don't have a defined limit, then the limit does not exist at that point. So as a conclusion, we can say that the limit exists at x equals to 2, but the limit does not exist, the limit exists. Let's write it, because otherwise we lose the the structure. So the limit exists when x approaches 2, but it does not exist when x approaches 3. And besides that, when x approaches 2, what happens when we approach any other number except for these critical points? Well, the limit will exist, because that would happen just by substituting a into x. So the limit over here, as x approaches a, we would substitute a into x, and we would have a defined limit. We would have this following thing: a squared minus 6x plus 8 over this whole thing. So the limit exists for all values except for that critical point, except for the point of 3. In that case, it's literally not defined. Hope this makes sense. We are done.